In this sum, we need to compute the normalized autocorrelation of the signal x of n is equal to a power n into u of n for 0 less than a less than 1. The general formula for autocorrelation is gamma xx of L is equal to sigma n is equal to minus infinity to infinity x of n into x of n minus L for L is equal to 0, plus or minus 1, plus or minus 2, and so on. So now let's substitute the value for L as 0 first. So we'll get gamma xx of 0 is equal to sigma n is equal to minus infinity to infinity a power n into u of n. This x of n is taken from the question, and for x of n minus L, substituting the value for L is equal to 0, we will get a power n minus 0 into u of n minus 0. Now this u of n is a unit step function and its value is 1 in the range n is equal to 0 to infinity. So we will get a power n into a power n, which can be written as a power 2n. So the final value for gamma xx of 0 will be 1 by 1 minus a square. We get this from the formula sigma n is equal to 0 to infinity a power n is equal to 1 by 1 minus a. We had a power 2n, so we will have 1 by 1 minus a squared. Now we will substitute the value for L as 1. We will get sigma n is equal to minus infinity to infinity a power n into u of n, a power n minus 1 into u of n minus 1. From here we'll take a power minus 1 outside, and this u of n is nothing but the unit step. This u of n and u of n minus 1 will be 1 in the range 0 to infinity, and inside we'll get a power 2n. Now this can be expanded using this formula, so we will get 1 by 1 minus a squared, and multiplying with a power minus 1 we will get a power minus 1 by 1 minus a squared. Now we can write the general form for this as, for L greater than equal to 0 we will have gamma xx of L is equal to a power minus n by 1 minus a squared. So when L is equal to 1 we will have a power minus 1 by 1 minus a squared, and for L is equal to 2 we will have a power minus 2 by 1 minus a squared. Now for L less than 0, so we have to substitute L is equal to minus 1. We will get sigma n is equal to minus infinity to infinity a power n into u of n into a power n plus 1 into u of n plus 1. So we will get a into sigma n is equal to 0 to infinity a power 2n. On expanding this we will get 1 by 1 minus a squared using this formula, and multiplying with a we will finally get a by 1 minus a squared. So the general form can be written as a power n by 1 minus a squared. So when L is equal to minus 1 we will have a by 1 minus a squared. For L is equal to minus 2 we will have a squared by 1 minus a squared. Now we have to tabulate the values for L greater than 0, L equal to 0, and L less than 0. So write gamma xx of L is equal to, and draw the flower braces, and write for L greater than 0 a power minus n by 1 minus a squared. For L is equal to 0, 1 by 1 minus a squared, and for L less than 0 a power n by 1 minus a squared.